The most important company in the AI race might not be NVIDIA. It might be the local electric utility. Because big tech has discovered something uncomfortable. You can buy the chips, hire the engineers, and build the model. But if you cannot plug it in, you do not have an empire. For most of the internet's history, technology felt weightless. A search result appeared instantly, a video streamed from nowhere, a message crossed the planet like it was made of air. But the internet was never weightless. It was always metal, concrete, fiber optic cables, cooling systems, backup generators, and enormous buildings filled with servers. We just did not have to think about it. Now we do. Big tech is running into a physical limit, not a software limit, not a talent limit, not even just a chip limit, an electricity limit. The largest technology companies in the world are now building data centers so large that they look less like office buildings and more like industrial cities. These facilities need power every second of every day. They cannot simply pause because the sun went down. They cannot wait because the wind stopped. They cannot politely slow down because the grid is busy. AI does not sleep. Cloud computing does not sleep. Streaming, search, social media, advertising auctions, enterprise software, and recommendation systems do not sleep. So the electricity cannot stop. And this is where the story gets strange. Big tech spent the last 20 years trying to convince the world that its products were digital. Now its future depends on some of the oldest industries on Earth. Power plants, transmission lines, transformers, land, water, gas turbines, nuclear reactors. The next internet war is not just happening inside a server rack. It is happening on the power grid. According to the International Energy Agency, electricity demand from data centers jumped sharply in 2025, while demand from AI-focused data centers grew even faster. The same agency expects global data center electricity use to roughly double by 2030. In the United States, the Electric Power Research Institute has warned that data centers could take a much larger share of national electricity use by the end of the decade. These forecasts are not perfect. The future of AI usage is uncertain. Chips may become more efficient, software may improve, some hype may fade. But even with efficiency gains, the direction is hard to ignore. The more useful AI becomes, the more people use it. The more people use it, the more compute companies need. The more compute they need, the more data centers they build. And the more data centers they build, the more electricity becomes the bottleneck. This is the hidden cost of the AI boom. Not the monthly subscription, not the chatbot interface, not the shiny demo where a model writes a poem or builds a website. The hidden cost is that the digital economy is becoming one of the most electricity-hungry industries in the world. And the companies that win may not be the ones with the best app. They may be the ones with the best access to power. For years, the simple story was that big tech needed better chips. And that was true. NVIDIA became one of the most important companies in the world because its GPUs were perfectly suited for training and running large AI models. Microsoft, Amazon, Google, Meta, OpenAI, and countless others all needed the same thing: more compute. But compute is not just a chip. A chip by itself is useless. It needs a server. The server needs a rack. The rack needs cooling. The cooling needs equipment. The building needs land. The land needs permits. The facility needs fiber connections. And all of it needs power. Constant power. This is why big tech's behavior has started to look different. These companies are not just signing cloud deals and buying chips. They are signing power agreements. They are working with nuclear companies. They are studying advanced geothermal. They are buying renewable energy. They are exploring gas generation. They are planning around transmission bottlenecks. They are acting less like software companies and more like energy companies with better branding. Microsoft backed a deal tied to restarting the 3 Mile Island Unit 1 reactor. renamed the Crane Clean Energy Center, to supply power for its data center needs. Google signed an agreement with Kairos Power for advanced nuclear reactors that could provide up to 500 megawatts of carbon-free electricity by 2035. Meta signed a 20-year agreement with Constellation for more than 1,100 megawatts from the Clinton nuclear plant in Illinois. Amazon expanded a nuclear power relationship with Talon Energy to support AWS data centers with electricity from the Susquehanna plant in Pennsylvania. These are not normal software company decisions. These are industrial strategy decisions. And they reveal something important. Big tech does not just want electricity. Big tech wants reliable electricity it can control. A normal business can survive some friction. A restaurant can pay a higher power bill. A retailer can open in a slightly worse location. A factory can plan around electricity prices. But a hyperscale data center is different. It is a machine built around uptime. If the power is unreliable, the business breaks. If the grid connection is delayed, the data center sits unfinished. If the local utility cannot support the load, the entire project becomes a very expensive warehouse. And that is why the race has moved upstream. It is not enough to rent space in the cloud. It is not enough to buy chips. It is not enough to announce a model. The real question is whether you can secure the physical resources to run the future. This is also why the geography of technology is changing. For a long time, tech power was associated with places like Silicon Valley, Seattle, and New York. But the new map of big tech includes Northern Virginia, Ohio, Iowa, Pennsylvania, Texas, Arizona, Ireland, Singapore, and parts of Scandinavia. Not because they are glamorous, because they have land, grid access, tax incentives, cooling conditions, fiber routes, or nearby power generation. The cloud is not in the sky. The cloud is wherever electricity is cheap, reliable, and available. That changes the economics of the entire industry. The old internet rewarded companies that could scale software cheaply. The new AI internet rewards companies that can scale infrastructure faster than everyone else. And infrastructure does not move at software speed. A new app can launch in weeks. A data center can take years. A transmission line can take even longer. A nuclear plant can take longer still. That gap is the problem. Tech moves fast. Electricity does not. The strange thing is that big tech helped create this problem by making computing feel limitless. For consumers, the internet trained us to expect abundance, unlimited storage, unlimited scrolling, unlimited streaming, unlimited search, unlimited AI prompts, at least until the paywall appears. But there is no such thing as unlimited infrastructure. Every query lands somewhere. Every video is served from somewhere. Every AI answer is calculated somewhere. And somewhere has a power bill. For years, data centers became more efficient. Companies improved cooling. Servers became better. Chips became more powerful per watt. Software became smarter. But efficiency created a paradox. When computing gets cheaper and better, people use more of it. When AI responses get faster, companies add AI to more products. When models become more capable, users ask them to do bigger tasks. The system improves, but demand expands. So the bill keeps growing. This is not just about one person asking a chatbot to write an email. That single request may not use much energy. The issue is scale. Millions of users, billions of queries. Companies embedding AI into search, shopping, coding, design, customer support, finance, healthcare, advertising, and office software. AI agents that do not just answer one question but take many steps in the background. The more invisible the work becomes, the easier it is to forget that it is still work. This creates a new kind of competition. Big tech companies are no longer fighting only for users. They are fighting for megawatts. They are fighting for permits. They are fighting for grid connections. They are fighting for long-term power contracts. They are fighting for the right to build massive facilities in communities that may or may not want them. And that creates tension. Data centers can bring jobs, tax revenue, and investment. They can also strain water systems, use huge amounts of land, and force utilities to upgrade infrastructure. In some regions, residents are asking a simple question. If big tech needs all this electricity, who pays for the grid upgrades? The company? The utility? Or everyone on the power bill? That question matters because data centers are not spread evenly across the world. They cluster. They appear where power, land, and fiber are available. And when too many appear in the same place, a local grid can feel the pressure long before the national numbers look dramatic. The global percentage may look manageable, but the local impact can be enormous. That is why Northern Virginia became famous as Data Center Alley. That is why utilities are suddenly central to the technology story. That is why old nuclear plants are becoming valuable again. That is why gas turbines, transformers, substations, and transmission lines are now part of the AI conversation. The boring parts of the economy are becoming strategic assets. This is the part big tech does not usually put in the keynote. The future is not just sleek assistants, smart glasses, AI agents, and personalized everything. The future is also concrete pads, copper wires, cooling towers, steel transformers, and local planning meetings. The magic needs a power socket. So what happens next? There are three possible futures. In the first future, big tech gets what it wants. Utilities expand, nuclear plants stay open, new energy projects get built, data centers become more efficient. AI keeps growing and the power grid bends without breaking. That is the smooth version. It is also the version everyone wants to believe. In the second future, the bottlenecks get worse. The chips arrive before the electricity. Data centers are planned faster than grids can connect them. Transformer shortages slow projects down. Local communities push back. Power prices rise in crowded regions. Smaller companies get squeezed because they cannot sign the same long-term energy deals as the giants. In that world, electricity becomes a moat, not just a cost, a moat. Microsoft, Amazon, Google, and Meta can afford to reserve power years in advance. They can fund new generation. They can sign nuclear agreements. They can build data centers near power plants. They can pay for infrastructure that smaller competitors cannot touch. The AI race then becomes less open than it looks. Anyone can build a clever app. Far fewer companies can build a global compute empire. And almost nobody can casually secure gigawatts of electricity. That is the hidden leverage. In the third future, the energy problem changes what AI becomes. Companies may be forced to make models more efficient. They may route simple tasks to smaller systems. They may charge more for heavy usage. They may limit free access. They may design AI products around the cost of inference, not just the excitement of the demo. The result may be less magical, but more sustainable, because every technology eventually meets economics. The first phase of the AI boom was about capability. What can the model do? Can it write? Can it code? Can it reason? Can it create images, summarize meetings, answer questions, and act like a tireless assistant? The second phase is about distribution. Who gets users? Who owns the workflow? Who becomes the default tool inside companies? But the next phase may be more basic. Who can afford to run it? And underneath that is an even simpler question. Who has the power? Literally. This is why big tech's electricity problem is so fascinating. It turns the most futuristic companies on Earth into buyers of very old things. Land, energy, water, steel, wires, permits, political patience. The internet was supposed to escape the physical world. Instead, it is becoming more dependent on it. For years, big tech's advantage came from software that could scale almost endlessly. Copy the code, add more users, expand the network, sell the ads, rent the cloud. But AI is bringing the industry back to Earth. Not metaphorically, physically. The companies that once talked about moving fast and breaking things now need slow, regulated, expensive infrastructure that cannot be downloaded. That may be the real twist. The future of big tech may not be decided only by the smartest model or the most elegant product. It may be decided by who can build the largest machine around it. A machine made of chips, data centers, cooling systems, power plants, and transmission lines. A machine that turns electricity into intelligence. Big tech is not running out of electricity because the world has no energy left. It is running out of the right kind of electricity, in the right places, at the right time. And in the next phase of the technology race, that may be the difference between owning the future and waiting for permission to plug it in.